So yeah, this is the first time I'm giving a talk at a camp, and I did the same mistake like Larry did, and I just submitted a lot of proposals, and guess what? Many of them have been accepted. So let's see how well this goes today. Hi, I'm Simon Micro. I'm a software and hardware engineer at a company, and in my free time I have too much time to hack around with things. I'm part of the cast have Osnabrück, which you can find in Osnabrück as well. And this camp, I'm fiddling around with the network of the Duck community. I don't know, if you want to play around with network, come to me. I know. I also like to nerd about stuff, and this is one of those results, a random talk about networking. We will take a small look into Ethernet, VLANs, and how to use it with OPNsense, and of course all the pitfalls you can encounter if you're using OPNsense. And then we will continue with WireGuard and side-to-side linking, because if you're playing around with OPNsense, this can be a magical topic you will stumble into sooner or later. So yeah, this talk is fiddled with lessons I've learned from my own mistakes, so you hopefully don't make them. But yeah, feel free to lecture me about stuff you also did wrong after the talk. I have more slides prepared than I will probably have time, so I'll speed a little bit through it. So yeah, I have also gathered all the experience in my own home lab since 2021, so I made a lot of mistakes. So yeah, let's get started. Yeah, just a small disclaimer, this talk is targeted at the beginning for the beginners, and then we'll dive a little bit more into advanced topics with the side-to-side topic, so side-to-side linking. Yeah, I don't know. General advice, if you're playing around with OPNsense and networking, use Linux or something, because you can dive deeper and fiddle around with settings and figure out why it is not working. So yeah, okay. Let's get started. Networking 101. Really quick start, Ethernet and VLANs. Ethernet, Internet Protocol, is on top of this, like V6, V4 and V6. You all probably know those IP addresses, nothing new, just 4 bytes, RFC, whatever, old. We also have IPv6, which is much, much longer, and with longer bit masks, you can also make more mistakes. And it is quite fun fiddling around with IPv6 and not getting it working in your home lab. IPv6, as I've said, has much bigger address space, but also you have other advantages, like you can get a global prefix, which allows you to directly on your machine have the global IP address and discard NAT-ting or something, which is, yeah, quite nice. Furthermore, in IPv6, you don't have to explicitly assign addresses. Like we don't need to have a DHCP server running on, for example, your gateway. You can do this, for example, for prefix delegation, but with stateless auto configuration, Slack or something, we can have other advantages with IPv6. Yeah, okay, so VLANs. We've now talked about Internet Protocol, which everybody knows, but VLANs is maybe a little bit more niche topic. Imagine your router doesn't have a port for every network segment you want to open up. For example, network segment for a guest network, or for example for your home network. You could of course use subnets or something, but these aren't physically separated. Somebody could just assign himself another subnet IP and then go on with his life. So in Ethernet we have a frame which encapsulates all the packets. This is like the frame. There are some bytes in there. I don't know, we don't need to talk about all the fields, because this is the interesting part. Just by throwing 4 additional bytes in, we can add a VLAN tag. So a VLAN tag, what is this? Like on technical details, is just an extension to the classical Ethernet frame. As I've said, it's just 4 bytes, so you're not like adding much more information in there. And a VLAN tag is basically a number in the range from 1 to 4095. The other ones are reserved. Don't use them. And yeah. We can use it now. No, we have VLANs. Funny. But VLANs aren't spoken by many devices naturally. You need to add this tag. You need to remove it from the packet so they can be understood by normal devices. For example, your toaster or fridge, if they're using Wi-Fi. And now the question arises, how do we insert and remove this tag if we want to play with it? For this, the sad news is get an old managed switch or something. Don't get the cheap ones, because they're like only switching a few ports together, but not actually doing VLAN tags, and then you will have trouble debugging this. Just get an old enterprise one. Make sure licensing is fine, so you're not having to pay and get a subscription to use it. So old networking gear is commonly fine. In this setup, we have a generic switch I've pulled from Pixabay, like an image, and we're now contacting VLANs, which is basically we have a LAN cable and with multiple different VLANs. I've now marked with color, and they're being dropped into a trunk port, which is the first one, and we can then redistribute them over access ports, so a port where only one VLAN is there. Here at the trunk port, the VLAN gets inserted in a tagged way, so the tag is still part of the Ethernet frame, and at all the access ports where the hardware, the switch itself, is automatically removing and inserting the tag whenever the packet leaves or enters the switch. So, and also there's a little bit of magic going on where the MAC addresses are being learned and whatever. We don't need to worry, we can basically just span up multiple isolated networks over the same device, and we can configure it in software. Of course, you can also just pass through all the VLAN tags over another trunk port and attach another switch, so we can do chaining and all the fun stuff if you have a bigger network at home, like 54 ports, I don't know. So, yeah, network, really quick. So let's get started with OPNsense, the actual topic or the more interesting part. OPNsense, like to just throw out some marketing terms, this is the web interface. Maybe you have seen it, maybe you have not. It's from the more recent releases. It is an open source implementation of a router, firewall, gateway, whatever you want to talk, whatever you want to name it. It is based on FreeBSD, which basically means if you have some hardware, it's likely not going to work. You have to buy hardware for FreeBSD because the kernel has limited hardware support. So you cannot just use any old hardware from any old vendor with some enterprise equipment or something. It may not work. It is original fork from PFSense, which is still an active project and still maintained. You can use it, but OPNsense has in my humble opinion, much nicer user interface. So yeah, this is just counting for it. On the topic of user interface, OPNsense is like primarily being configured over user interfaces. With old network gear, for example, your switches, you will likely have some other means of configuration, for example, using a serial cable or connecting with SSH. Technically speaking, you can OPNsense also do this, because in OPNsense, the whole configuration is just part of one XML file. You can just download and edit, but you can also break it using this way, so don't. And yeah, just use a web interface. If you broke the connection to a web interface, you probably broke your network already, so don't worry. Yeah, next point. Oh yeah, if you have a family or other roommates, depending on the internet, use high availability. They're really pissed if you like to tinker with it and break it in the midst of a World of Warcraft session or something. Not that I'm speaking of experience. Okay, so backups. Really, really important. Please back up your OPNsense instances. There's a nice... Well, that XKCD got mangled. There's a nice speaking, no backup, no pity, and yeah, if you break OPNsense, you're probably breaking your internet access, which isn't nice. So please have a plan B. In this case, OPNsense has an extension in there, so it has plugins, and there's a plugin out there I would really recommend you to use, git-backup. It is just a plugin to notice the person or the script doing the changes and automatically submitting them to GitHub, any Git service, sorry, not GitHub, not only GitHub. Also, use something like a fallback plan. Like if you messed up networking, have a dedicated port on your OPNsense with a static IP or something, so you're not relying on any service with an own firewall rule assigned specifically to that interface, so you can still access the web interface. And if you manage to break that, have a serial cable or something, and the port actually enabled in BIOS, so you can actually go in and recover the system without reinstalling, because reinstalling an image over cellular connection isn't fun. Also, if you use, like, do not just set up a dedicated port, also enable SSH, which is disabled due to hardening policies by default. Just enable it. You're at home. You're not a state actor, not a state target, hopefully. So it should be fine. Yeah, Git server. Also a lesson I learned, don't place your Git server you backup to behind your firewall, because if you break it, you're also breaking your Git server. So yeah, don't fall into this pitfall. Like, it happens, just you add in the repository, add it there, backup, you break it, and Oh, now you have a problem. Yeah, on the topic of bricking, my SSD died once. I have never thought this would be possible. A friend of mine got himself locked out, and also his SSD got broken. So I don't know whether the lesson is do better backups or whether you should buy better SSDs. This is up to you to decide. But yeah, just have a fallback. So don't skip backups. So, networking design. Hi. We have talked about OPNsense, general where it's coming from, please back up your stuff. Now we want to start networking, but before we just start networking, you should probably have a plan. So in our design, we have the Ethernet as the globe symbol up there. We connect OPNsense, we're just using a WAN connection. We throw in some VLAN tags and just stream all these network segments into our trunking port of the switch. And after this, we can do separate ports. I've just marked all the similar access ports in one color. So we have, for example, the green for smart home stuff. So you have to isolate it because it's not getting updated often. So you should probably do this. And of course, we have our classic LAN connection. You can also segment further. The general rule is just less is more. Don't try to segment every device out, although this would be the best. It just makes everything much more harder. Also try to use user groups or target user groups and not just segment for each room, because rooms tend to change in their meaning, and also you have often mixed use cases, some smart home in your living room, and now everything gets messed up. Just use user groups. From my experience, is the best way to categorize devices. So, configuration. We now have a plan, at least more or less, how to implement it. First step, assign interfaces. Create VLANs first. It is just under the same settings, so you have some way of actually communicating with the new VLAN tags you just imagined. Also, I would recommend you to use LAGs, link aggregation groups. Don't worry about the specific option you select now. I think the default is like failover or active failover. This is fine for you. There's no specific talking with the switch involved. But if you later want to change to a more high-capacity connection to your gateway, because your gateway should have the fastest connection in the network, this makes it much more easier. And also, hopefully, without downtime, you can just flip the type and just 2 pings dropped, and then you're up running again. If you directly assign to interfaces, this gets a lot more messier, and you may need to restart and reassign interfaces, and your roommates don't like that. So yeah, okay, and yeah, also the other notes there, you should have the fastest link, otherwise you will have some congestion in your network without you noticing. Okay, 1. Just use DHCP. Probably you don't have, you already have an ISP modem or something. Just put your OPNsense behind that. And hopefully you get a public IPv6 prefix. This is like a dual stack issue. Just Google dual stack versus dual stack lite. Sorry, not Google, web search. I don't know, some vendors are just handing out IPv4 only if you're using your own modem. Some German ISPs are quite good with that. So hopefully you get IPv6. But this is really up to you whether you actually want to use it. In your LAN site, just for each VLAN, assign an IP address, a static IP address, and then you're good to go. You can start communicating, hopefully. At least in theory, we'll see why this isn't the case. You should also throw in a DHCP server, because this is one of the primary tasks your previous generic ISP modem did before. He handed out the IPv4 addresses. We now need to enable this actually in OPNsense. Just do a web search, you will find it out. It isn't that hard. On the topic of UDP broadcast relay, you often have something like a smart TV or something, and they are shouting constantly into the network, hey, I'm here. If you're doing network segmentation, for example, smart home versus your private devices, those shoutouts, those broadcasts aren't crossing the network boundaries anymore. If you explicitly want to enable them, UDP broadcast relay is your friend. It's a plugin which should fix it. UPnP. Imagine port forwardings. You can do them manually in router nowadays, but if you're using OPNsense, you need to enable UPnP actually for that. So devices can request those port forwardings automatically. There's a certain a Japanese game console manufacturer with a big N on the background. I don't know whether you know them, but they're quite good and not speaking proper UPnP and not accepting everything which is given to them. So getting those consoles working again is quite a hassle. Also, by the way, if anybody of you figures that out, I would be liked to hear from you, because it was a nightmare. Okay, so next part. Firewall and routing. Turns out, after you set up everything, you will quickly realize nothing is working. You cannot enter internet, you cannot reach your other devices, because OPNsense by default blocked everything. You need to add rules for that to actually get it communicating. Rules, where to place them. Under firewall rules, you can assign rules, and there are two basically for every interface, your interface name, and one floating section. There's a distinct difference in between. Floating does not match on the physical hardware interface anymore. So you should probably set something like a source VLAN. Otherwise, basically everybody from your WAN connection or internet can access your private stuff if you don't be careful with that, if you aren't careful. So try to always prefer interface, but in special cases, we will also touch today, we need to actually place them with floating. Also, if you start using network groups, which I really, really recommend you, oh, this is too far, you should try to place them within floating, because sooner or later you will extend those groups to include IP addresses of other interfaces, and then you're screwed, because you need to manually recreate the rule, because you cannot just copy it over. Okay, yeah, also, please set up your backup. I know you didn't, but please set it up now, because when it's adding rules, you will probably break it sooner or later. And yeah, you don't want to get locked out of your internet. So yeah, merge shared attributes. I've touched groups and categories before. Try to deduplicate them. If you have, for example, a device which has a fixed IP, for example, your printer in your smart home network adds this IP to an alias and then reuse them over and over. And for every network device or every segment needing to access the printer, puts a rule to allow access into a group and not into each network. Because if you need to change it later on, this makes it so much easier. Because in addition to that, in OPNsense, you cannot just search for all rules containing an alias. You need to click through every interface. And if you do more and more segmentation, this will get tedious. So yeah. I don't know whether you've read on slide, I skipped over it. In aliases, you can use DNS names, and this allows you to make them quite powerful. For example, only access to youtube.com, and it's just directly being resolved. I don't know, fiddle around with it. Pitfall here, those aliases aren't being updated based on the domain TTL, but just periodically. If you just encounter this, keep this in mind. Okay, so tools them all. The animation is broken. Yes. Nice. Everything working here. First step, create a custom reject rule. By default, it drops everything, but doesn't log it. If you enable the logging, you now see everything being dropped, which isn't helpful if you're looking just for one device. Being unable to speak with the printer. Just add a custom rule in there, set the source IP address filter, and enable logging, so you have at least a way to observe what is going on. Allow access to OPNsense, because at this point, probably if you're connecting a device to OPNsense, it gets an IP address, but it cannot access OPNsense actually, or the internet, so I don't know, just add a rule in there. For example, allow DNS, allow DHCP. You're fine. Third point, allow internet group. We have now connected everything. We actually want to go into the internet, so create an own group, assign the interfaces into the group, and now add all the rules for accessing in the internet into this one. You may imagine this rule would look quite simple. So everything from the internet group is able to speak to everything. No, you now basically build a wildcard route which allows everybody from your network to communicate with every other network segment. Try to use something like everybody from this group is able to speak to anything except the internet group. So you're preventing crosstalk without explicit permission within your segments. Also, if you then start off with the next point, the fourth point, creating your own rules, I really like to use a category called testing only, so you know this rule was just a temporary measurement because something didn't work. Use it, and if you see those rules later on, a week later, and you're wondering why is this rule here, you can just directly disable it and remove it again. No worries. If you break something, it's on you. So, let's continue. Not. All right. Did something crash? Okay, here we go. Now I think I have to press. Oh, it works again. Nice. Firewall routing IPv6. I touched this topic before. You hopefully got a global IPv6 prefix, so we can now actually start talking IPv6. Sad story is IPv6 is complex, and it will probably mess up your network setup if you're doing it improperly, and most of the time it doesn't work. So maybe a beginner shouldn't really spend much time. Get your IPv4 stuff working first. IPv6 as I mentioned, much more complex. Because you have a global prefix, this global prefix, or the whole IPv6 address, needs to be published in DNS records if you want to allow direct access to it. But this brings another hurdle. You need to get this IP address, the device assigned itself, from the device into your external DNS provider. There are solutions out there, but you will they then need, for example, some mass deployment options. For example, all your servers, if you have 5 or 6 servers, to dynamically update these records because your ISP probably changes the IPv6 prefix at some point, and yeah, then you need to update it again. IPv6 with multi-WAN is much harder. Well, there are issues associated with this. Just skipping over this multi-WAN is like a nightmare in IPv4 already and breaks your connections all the time if your ISP isn't stable. So yeah, smart home with IPv6 isn't really often not IPv6 capable, so don't worry about those network segments, just keeping them on IPv4. By the way, why would you ever allow a smart home device to talk to the internet? Keep your data local. Yeah, okay. Just my conclusion, don't worry about IPv6. It's not worth the hassle if you're just starting off. Okay, let's continue with the actual side-to-side topic. We have only 5 minutes left, so I'll try to speak a little bit more fast. OPNsense allows you to do WireGuard tunnels, for example, in between. There are some pitfalls associated with this. Oh, nice, now everything is falling apart. Dynamic IPs with WireGuard are bad, because WireGuard only resolves your IP address once at start. OPNsense has the workaround built in, but if you're using other clients, for example, an old Raspberry Pi or something you have laying around, you need to use other scripts to get it actually working. And even then, it's a little bit fiddly. So yeah, it's possible. Try to use just OPNsense. They have a workaround. Multi-WAN, from my own experience, maybe this is a bug. If you have multi-WAN connections and use side-to-side tunnels, there's a high chance those connections are infinitely sticky. So even though your primary internet access has returned, you're still stuck on cellular. I don't know why, but the state doesn't seem to probably expire in the contract table. Maybe it just gets fixed at some point. And also, WireGuard is peer-to-peer by design, so try to use the first side-to-side links first, and only. So, side-to-side configuration. Tunnel network, what is this? Yeah, it's basically just an IP address of the interface itself, and just assign a 24 prefix and your own device's 32 address route for each peer, and then you're fine. Nothing to worry about. Also, there's something else in there. If you're not really sure, you should probably establish 2 side-to-side links, just in case you mess up the primary one with some routing, you still have the secondary access. Speaking from experience. Okay. Firewall routing. Now we have 4 bigger points. Granting external access. If you set up WireGuard, it doesn't have that many fancy logs because it's running in kernel and you don't see anything going on. So if you want to grant external access, make sure to allow it actually in Firewall, otherwise you will waste a little bit of time. Allowed IP, if you're coming from classical networking, it's just an alias for adding a route to a network. And I had a discussion with a colleague before. No, there isn't much fancy stuff with ACLs going on as written in the white paper. They are directly hooking into the kernel API for adding routes. So I don't know. If you want to have your rules working with WireGuard, keep them floating. So always add them floating, because the WireGuard interface of OPNsense is just a participant in the network and not actually routing. So the rules aren't being observed at the interface. They need to be in the kernel, so just generically in the kernel. So just add them floating. Yeah, and also add the rules on both sides. Otherwise, you will have trouble because it's not working. You basically have the choice to add the source or a target. I don't know. There are the points. It always depends. Target is a little bit more secure in case you get compromised, but then you need to maintain the aliases for all the rules on both sides. The ideal world, you would add them to both sides, but this is like a maintenance overhead you really don't want to encounter. If you really want to have it, sure, go for it. But from my experience, just keep one choice and roll with it. Yeah, okay, stuff going wrong because, I don't know, I also had quite a fun with all the stuff. I'm using multi points to multiple uplinks, and I want to have my service reachable over both links. You can do this with OPNsense, but of course, I messed up with IP whitelists, and turned out if you change the DNS override, you were able to access the internal networks over secondary ingress because it was a side-to-side tunnel within the same prefix. shit happens. Yeah, also, do you failover handling properly? I wrote a tool for this in Rust, because if you have multiple entry points, you want to switch between them using DNS, so no external load balancer required. There's a tool for that. I don't know, if you want to use it, feel free. Yeah, otherwise, if you have still time, there's a little bit random stuff to nerd about. Sooner or later, you will maybe encounter it within your network, and yeah, I think that's it. Thank you.
Thank you very much. That was exactly to time to like the second. We said before, so there wasn't time for questions with the talk, but if anyone wants to buy Simon a drink afterwards, I suspect you may not be walking much later. But yeah, feel free to buy him a drink, ask any questions, etc. And yeah, thank you very much again for a great talk.